Hi, student. This video will get into the lesson and we call it factors of differences of square. And to factor this, it's very easy to use a formula. So I'm going to introduce you the formula. Let's say if you have the algebraic expression a squared minus b squared equal. So anytime you see the expression with the pattern like this, you can break it down into brackets like the way we factor, right? And the answer will be a plus b times with another bracket, the same a minus b. So the base for this expression is a, right? And a squared subtract another base b. If we apply this formula pattern, the left side right here, right? Left side always equal the right side. Or the right side, the arrow go backward and forward, always equal the right side, always equal the left side here, right? So this left side equal this right side. Now, why it like that? I'm going to show you and using the number so that I can prove to you we got to accept this formula. We will have to accept the genius of mathematician 1,000 years ago. They invented this formula and let's check, okay? Example, if I have the expression, the first example, I'm going to prove it to you the formula is correct. And I'm going to show you in symbol. So I use a number. I'm not going to use a letter, right? So let's say if I have a number 36 minus another number is 81. Now keep in mind, this is not the subtraction. It is a subtraction, but our purpose in this lesson is not subtracting this number. Our purpose is factoring this expression, right? By applying this formula, okay? So now if I see the 36 minus 81, I didn't see where's the a squared, where's the b squared. So to know this, I'm gonna take the square root of 36 so that I can go back to the base, which is 6 squared 36. I cancel the power with the root, and I know the base have to be 6. Right? That's how the way we take the root by hand instead of calculator. So I'm going to rewrite this 36 becomes 6 to the power 2 because they're equal. 6 to the power 2 equal to 6. The same like this one, I recognize this is just 9 to the power 2. 9 to the power 2 is 9 times 9, and 9 times 9 is 81, right? So by doing this, and how do I get 6 and how do I get 9? Again, I know it in my head, but if you don't know, you're not familiar with the power and the root, you just use the calculator and take the square root of 36 to go back to the base of 6. Take the square root of 81. In your calculator, key in square root of 81, you go back to the base of 9, right? And to get back up to 36, you have to square it. 6 squared is 36. 9 squared is 81. You have to power 2 back to the question because we never can change the original question. If we change the form of it like this, instead of write 36, we make sure it doesn't matter what we change, they have to be equal, the value, right? So 6 to the power 2 is 36, 9 to the power 2 is 81. Now, why do I bother to do this? Because I want to apply the formula to factor this expression, right? So I have to get back into this form. I have to have a pattern of a squared minus b squared so I can apply the right-hand side here. So this one is just the same like this expression, right? A squared is 6 squared minus is minus b square is 9 square. I give this number back to the pattern of a square minus b square so that I can apply this formula. So now I'm going to apply the formula. I'm going to break this expression into two brackets, multiply together. In here, I follow a. My a is number 6, right? I follow the expression plus sign. My b is 9 here. So 6 plus 9 times with a minus b, which is 6 minus 9. Now, I will have to prove to you that the left side of this equation equals the right side, and that's why we have an equal sign here, right? And that's how we factor this expression in terms of two brackets, tie them together. When we expand, we get back the same. Okay, now let's check, okay? So 36 minus 81 is the left side of this equation. And if I use 81, I minus 36, I got 45. I got 45. But I have to carry the sign of negative because I lost more than I gained. That's how I add and subtract integer, right? So the answer for this expression, if I subtract them, I got minus 45, which is the left side here, okay? Which is minus 45. So everything here is the left side, okay? 36 minus 81 equal minus 45. Now I'm going to prove to you that if I simplify the right-hand side, I get the same answer, minus 45. Then I can conclude that left side equal right side, equal minus 45, right? So let's simplify it. Now, when the number inside the bracket is a number, you can add them, right? So this give me 6 add 9 is 15. 6 minus 9 is minus 3, right? 9 minus 6 is 3. Carry the side bigger number because I lost more than I gained. Multiply these two brackets, I got minus 45. So now I prove to you, yes, right side equal left side. 36 minus 81 equal minus 45. If I break this original expression, become two brackets, 6 plus 9 times 6 minus 9. I simplify the right-hand side. I got back to minus 45. So what does this tell me? It tells me that if I perform this formula, right, I got it correctly. I just prove it to you that left side equal right side. A square minus b square, 6 square minus 9 square equal a plus b times a minus b equals 6 plus 9 times 6 minus 9. And that because it is a number, I work it out and it proven to you that left side equal minus 45, the same as the right side equal minus 45. Okay, so up to this point of the lesson, we acknowledge that this formula is correct. So from now on, it's proven, right? Any formula we can prove it, right? We smart. Anyway, I'm just joking. So of course, the mathematician invented, got to be correct, right? And it's true. We work it out and it's correct. So this is just the number. I'm going to give you another example to prove that this expression is always correct. Doesn't matter number or letter, whatever, right? As long as we factor it right, we always get it correct. So example 2, I'm going to get into the x squared minus y squared. I'm going to ask you to factor this, right? Now you can see that the base a here replaced by x. but the pattern exactly the same. X squared, A squared, minus B squared. The base of B here is Y, but the pattern is still factor of difference squared. This is the difference squared. Difference means subtract. The square means this number square or power 2, the same by square, right? This is power 2, okay? Now, follow the formula. How do I factor this expression? Again, it will be equal to bracket time together. That's how we factor it, right? So we're going to put the A in here, follow the formula. Our A base is in terms of X. So X, right? Plus, follow this plus. Our B is Y. So X plus Y. Our A is the same X, except this plus sign become minus Y. Okay, so this is how we factor this algebraic expression using the formula, and we apply the formula and we factor it. It's very easy, right? Now, if you expand this to bracket, of course, you will go back to the left side like that. So let me skip this checking, right? Because I just proved it to you the first lesson already, that the left side here always equal right side here, right? So let me skip for this one, but let me go to a next number and you will see how it works. I will check for you, okay? Now, I'm gonna show you the next example, and let's say this time I have a number, okay? So let's say if another example, example 3, I have an algebraic expression 4x squared minus 9. Again, I have to give this expression back into the pattern like this so that I can realize what is my A, what is my B in here, right? So the way I'm gonna go back to the base mean I have to take the square root of number 4, and square root of number 4 is 2, right? 2 to the power 2 is 4, right? And of course, the X is already have power 2 right there. So instead of write like that, I'm going to combine them and make it the bracket. I'm going to put a 2 outside, right? So power 2 here will cover the whole, each member inside here. If I distribute back, it will be 2 to the power 2, which is 4x squared, right? Minus, I'm going to take square root of 9 because square root of 9 equals 3. And if I do 3 to the power 2, I get back to 9. So I'm going to make it become 3 to the power 2. At this point, you will see, oh, what is my A? My A here is 2x. What is my B? My B here is number 3. And I have A squared minus B squared. Now I'm going to factor this. How do I factor this? To bracket again. As long as I know what is my A and what is my B, I can use this formula and put in here, right? So my A is 2x. This one will be 2x. My B is 3, and the plus side follow the formula, plus 3. My A is 2x. My B, except to see negative, right? Follow the formula, B is 3. So I break down this expression 4x squared minus 9. I factor it, become 2 bracket times together. A plus B times A minus B. 2x plus 3 times 2x minus 3. Okay, and that's how you recognize the base of the expression in here, okay? Because if you don't find out the base, you cannot factor it, right? So remember, we have a left side with the power 2, but once we factor them, everything go down to power 1, right? A to power 1, B to power 1, don't put a 2 in here, right? I have some students in the past make that mistake. I remember, that's why I remind you, right? when we factor them become two brackets, of course, they go down back to power 1 because when you distribute it, A1 times A to power 1 become A squared. B to power 1 times B to power 1 give you B squared. If you expand them, right? But when you break it like factor like this, make sure you don't put a square in here, right? On the left side, it have a square, but on the right side, there's no square or just power 1, okay? So this is the example 3. I'm going to give you another example. But let me prove it to you that yes, this two bracket equal the left side, okay? So let's prove that. Prove. I'm going to expand them, tie them together. 2 times 2x equal 4x squared. 2x times 3, top 2 arrow, and positive times minus, 6x. Now 2 arrow at the bottom, 3 times 2x plus, right, positive times positive plus 6x. 3 times minus 3, minus 9. Okay? Now, which one I can cancel? Remember, if you gain $5, but if you lost $5, one positive, one negative, exactly the same amount, it becomes 0, right? Basically, you can cross it, cancel it, right? So the same like this here. 6x and 6x exactly the same amount, right? One is negative, one is positive. They cancel out, right? You gain 6x, but you lost 6x. So at the end, you're not lost, you're not gain anything. So now your answer is just 4x squared minus 9. Now let's take a look at the left side here, right? They're exactly the same. So it proves to you that this formula is always correct, regardless what our expression on the left is. As long as it have a pattern of a squared minus b squared, we apply this formula, we do it, we factor, and it always correct. So this is, I checked the second time. The first time I checked for you using the number. This second time I checked using both number and letter, and it also work out. So I'm gonna, just from now on, I'm gonna show you how to do more complicated factors without checking, okay, to save our times. And my suggestion to you, after you realize that this working left side on right side, and that's the way we factor, we use the formula, we factor, copy it down, put it in your notebook, put it aside, make sure you don't lose it. And the best way to put is put in your hand, right? Remember this formula. Why I told you? Because it's useful. Anytime you factor, you remember this formula, you always do it correctly and fast, right? And how do you remember? So easy. This is not a hard formula to memorize, right? The pattern is differences of square, a squared minus b squared, equal the same base a and b, put in the first bracket with the plus sign, a plus b, and not power 2, right? This is the left side power 2, but when you break it down, it becomes power 1, right? On the right hand side. Time with a minus b. So the letter exactly the same. It's very easy to remember. And they are the same, AB, 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 except one bracket have a positive between them, another bracket have a negative between them, right? Positive, negative. Okay, that's all you have to remember. All right, now let me give you an example. Example 4. Let's say now you have an expression is more complicated. Let's say if I give you an expression of m to power 4 minus 16. All right. So again, I have to give this expression back to the pattern like that. It's hidden in here, I don't know. So to make it like a square, it will be m to power 2, right? On of this, inside the bracket, there's another power 2 outside because 2 times 2, this is the double power, right? You multiply when you distribute, right? So 2 to power 2, then another power 2, double power, it means 2 times 2 here is 4. So that's how you break the M4 into the square pattern, right? Square pattern, okay? Minus, how do we get the hidden b in here? Gotta be b squared, and the b in here is 4, because 4 power 2 is 16, right? So it's hidden in here. You got to take square root of 16 to get down to 4 and power it back again. So here, you know what is your a equal. Your a here equal m squared. And your b here equal this base, which is 4, right? So now you break this into 2 brackets and follow the formula. Put the a in here, your a is m squared. And plus side is plus, your b is 4. Put in here. Your a here is m squared again, right? And this time you have a square because this power is power 4, right? So that's why you have square. Now minus is minus, your b is 4, okay? So at this point, you will say, oh, am I done or not? What do you think? I'll give you one moment to think about it. Are you done with this factor? Remember, when we do reduce to lower fraction, we keep reducing until we have a lowest one, right? The same in factoring in math. We keep factoring down until we cannot factor further, right? So let's look at the first example, first expression, m squared plus 4. Now, this is nothing to do with it. It's just m squared plus 4. But take a look at the second bracket. Can you see another a square minus b square pattern? Yes, right? Because this is your a, m is the base of a, and the b here, if you take square root 4, this is like 2 squared, right? 4, you can break it, become 2 to the power 2. This is your b here is 2. So you have another a square minus the b square back into the left side of that. It means you can break this again, this expression again, into 2 brackets again like that, right? So I'm going to complete my factoring, okay? So the answer, the first answer, I'm going to copy this down. Now, why don't I break this one? Because this is not a pattern. Remember the sign here is positive, but where the pattern we have is a negative sign, right? That's why we call it differences. The sum, we call the sum is the positive. We call it differences when we have a negative, right? See differences. We don't have differences for the first bracket, so we cannot break it, leave it alone, the same exactly. Now we're gonna break this into 2 other 2 brackets again, timed together using this formula, right? So this one now will become a plus b, which is 2, right? Times with a minus b, which is m minus 2. So now this factor, the whole thing here, you can break it into 3 brackets instead of 2 brackets like we usually do. And that's we call a completely factor, okay? We complete it. As long as we see any pattern like that, a squared minus b squared, we're gonna break it again into 2 brackets, become a plus b times a minus b, which is our a in this example is m plus 2 times m minus 2. Okay, I hope that you understand, right? Actually, the idea is not so bad. So now at this point, I'm not going to expand them and checking for you again, because to save our time, we know the formula correct, we just follow it in factor. And that is factor of difference squared in our lesson today, okay? So again, I'm going to give you another example. And of course, our expression will getting harder and harder each time. It's more complicated with more letter and more number involved in, okay? So let's say I give you a very complicated expression now, okay? Let's say I'm gonna give you an expression of complicated one, which is number 5 example. 3a squared. You know what? I'm not going to use same letter. Let's use a different letter so that you know that we not use the same. And say 3 plus 2, instead of 2a, I'm going to say 2x. On of this is square. Minus 2 minus y on of this square. Okay, because it's complicated, I'm going to make the square bracket outside. Can you recognize this is our left side? Even though we have more expression, we have more number, we have more letter, but let's take a look at it. If you treat the whole bracket here as one number, at one whole number, so 3 plus 2x here is as your a, and you have squared outside. See that, right? This one. So take a look at and consider this as one number only. Don't break it down. Treat them as a whole thing, right? 3 plus 2x is your a, square is square, minus is minus. 2 minus y, treat it as a whole thing, as your b, the b is b in here. So this is your a, okay, your a, and the whole thing here is your b, okay? So this is how you take a look at it. And again, this is left side, we're gonna factor it and make it the right hand side, okay? I need the room for it. So we're gonna break this expression into right hand side, a plus b. What is our a? Our a is complicated, so I put 2 brackets, right? I open 2 brackets. 3 plus 2x is my a, right? This is my a plus is plus, b, this is b, right? 2 minus y is my b in bracket. I close the big bracket. So this is a big square bracket. This is my a plus b, a plus b from the first bracket here. I'm going to open another square bracket. Now I'm going to put in a minus b for the second bracket, right? And I'm going to put another small bracket because the expression is complicated. So I open 2 brackets again. I'm going to put an a in here. What is my a? 3 plus 2x is my a again, right? Treat it as a whole thing, as a whole number of a, minus, my b, what's my b? 2 minus y. Put in the bracket. And make sure you put in bracket, right? The sign here is the sign from the formula, right? We follow exactly the formula. The a plus b, so the sign here plus, this is a plus b, this first bracket, which is the whole thing here, time with the second bracket, which is the whole thing here, right? Our a plus b is 3 plus 2x for a, minus is minus here, and the b here is 2 minus y, okay? Now, because this is complicated, so I'm gonna have to simplify it. I'm gonna remove the first square bracket here and just put in the big bracket. We'll copy this down, 3 plus 2x. Now, this is plus side. So remember, once we have this between them, the plus, the sign between them, is no longer multiply. It only multiply if you don't have any sign and they just side by side, right? Like this, right? But if they have a positive, it means this is adding subtract, right? Make sure you distinguish the operation. So the plus sign here, we plus 2, I'm gonna put down plus 2. And because we have a plus sign in front of the bracket, nothing change inside here when we remove it, right? So it's minus y, still minus y. Now we can close small bracket. So you see that I remove layer by layer. I remove the first bracket. I'm going to put everything in perspective like this, right? I'm going to open another bracket. 3 plus 2x, copy it down, 3 plus 2x. Remember, this is not multiplied. There is a negative between two brackets. All what we do is remove the bracket, right? So negative 2, because this is positive. Once you have a negative outside the bracket, everything in here have to twist to the opposite side. So minus 2 minus positive 2 now become negative 2. Negative y now become positive y, right? To the opposite. And that's why we put in brackets so that we don't do incorrect the signs, okay? So at this point, we still have a complex expression. Now, I'm gonna have to go back up here to finish the question because I have no room, okay? So now let me say a little bit room in here by 2 minus y squared. Okay, so I'm going to simplify this expression. So I'm going to add them if I see anything in like term. Now this is 2x, this is y. They're not like term. I cannot add them. All what I do is put in equal 2x for the first bracket. 2x minus y, still minus y, because they are not like term, I cannot add them. What about number 3 and number 2 here? Yes, 3 add 2 is 5. So plus 5. That's how I simplify the first bracket. Or simplify the second bracket, okay? The second bracket from here, 2x plus y, again, they're not like term. I'm going to put in 2x plus y. 3 minus 2, yes, a number we can subtract as a like term. 3 minus 2 is plus 1. I'm done. So by simplify each small bracket again, this is how I factor the complicated expression here. Okay, now don't worry if you found it so complicated. As you get going, you will find more comfortable. If you practice more and more, practice make perfect, right? So I'm going to make sure you see the bar, right? So I'm going to erase this complicated example. I'm going to do another one for you. And don't worry, I will leave the last question for you to copy it back. Okay, the formula is somewhere there. So look at the formula, we do our factor. Now, let me do another example, which is okay. What example I should show you here to see. Okay. I'm going to show you another example, which is maybe this time I am going to use a same letter. Okay, so a plus b, all of them square, minus C plus D, all of them square. And you can see this is the left side, right? The whole thing here, the whole first bracket, treat it as one number, one base number. The whole thing here, A plus B is your A, right? Square, square, minus, minus. C plus D is B, right? Treat it as the whole thing, C plus D here as one number, C plus D is the B, and square is square. So now to factor this, we're going to follow our formula and break it down into two brackets like this. And we're going to put the A in here, the B in here. Okay, maybe we should have a square because it's complicated again. So our A will be A plus B for now. A plus B, that's our A. Plus is plus. Our B is C plus D, right? So I'm going to close this one. Okay, let me. So our A is A plus B, close bracket, plus is plus sign, right? Use the sign, plus is plus sign, B, our B is this expression, C plus D, bracket, C plus D. Now we're going to time the second bracket, our A is again A plus B, so this is the big square bracket. Open the small one, A plus B for our A here. Minus is minus, close this bracket and put down the minus sign here. B is C plus D, open the bracket, C plus D. Right? Now we can close the big square bracket. So now, after we follow the formula, we get A plus B is this A, plus it plus, this B is C plus D, right? Close the big square bracket. Open another big square bracket. A is A plus B. Minus is minus. B here is C plus D. We put in the bracket. Now I'm going to remove one by one layer and make and simplify it, right? So remove the big square bracket here and put A plus B, just copy. And what you do is just copy it down. Now the plus sign here, C plus D. So plus C plus D. We're done. Next, open another bracket. A plus B minus C and plus D, but because this minus, so it changed this plus D become negative as well. So now let's take a look back at these two brackets here. Can we add them? Now they become adding, subtract. A, B, C, D, none of them are like term. They are different letters. So that is the final answer. We cannot go further. If they are the number, all what we do is simplify them, add them together, subtract them together. If they are like terms, we do the same, but they are not like term. A, B, C, D. A, B minus C minus D. So that is our final answer. Okay? This is how you factor a complicated, apply the formula and factor exactly the way it is. I think that at this point, it's very good for you to have an understanding, but let me show you another expression, right? The only important thing in this factor is you figure out the base of the hidden number. Given you an expression, what is the base A and what is the base B? And now you recognize what is my A, what is my B, you put in a bracket, you tie them together, that's how you factor, okay? So for example, let's say if I give you a 9, I just give you a hint, I don't have to do all of them, 9A squared. If I asked you factor this factor expression, minus 25B squared. So what is your A? Right, you know what's your A. Your A should be 3, right? Square, 3 square is 9. A square, right? This is A square already. So you can put them in the bracket and you put 1 square outside instead of put both of them like that, right? So this is your A. If you distribute, of course, it will be 3 square times A square, but you don't need to distribute, right? You want to give back to the pattern like this pattern, right? So this is your A minus. From 25, you take square root 25. You got 5 power 2 is 25, right? So 5, again, 5 to the power 2 be the power 2. Instead of put down both 2, you just put them in one bracket and square. Now you know the whole thing here is your A, this pattern, minus is minus. The whole thing here is your B square. And as long as you recognize up to here, right, from this one here, you give back to this expression, give back to this. You know your A is 3A, right? So 3A, A plus B, your B is 5B, times what? 3A minus 5B. You get the right-hand side is easy, right? Just follow the formula, okay? So this is how you do it, and I hope that you enjoy my factor of differences square. We end the lesson here. I recorded so many times today. I'm getting tired because sometimes I record and it didn't go well the first time. Okay. So I hope that after our lesson today, you know how to do factors of differences square. I'm going to leave you this example at the last example for you to see how you factor it. And I'm going to leave you a few minutes for you to copy it down. And I'm going to close it, the lesson today. So this is the factor of differences square. Now, if you rewind the video again and again and you don't get it, email me asking, okay? And I will try to answer your email as soon as I can. Another way, you can schedule Zoom lesson with me ahead. I'm busy enough to make a video teaching and making lesson plans online for you guys, 5 courses, but I try to save times in case you have any question. I will try to answer your questions by getting in Zoom, but you got to schedule me ahead of times, right? Email me the nights before, and the next day I know that I can get on Zoom and help you out. Okay, you also can meet Mr. Dano on Zoom every single day to help you out as well. Okay, so at this point, I'm gonna summarize, okay, for you. This is A square minus B square. This is a pattern. As long as you see any algebraic expression with the pattern of A square minus B square, you can apply this formula. You break it down into 2 brackets, and you put an A in here with power 1, right? Plus B in here in the first bracket, times with A minus B in the second bracket. For example, if you have 9A squared minus 25B squared, you know you can make it become 3A on of this to the power 2. So this is your A squared minus 5B squared, 25, you break it, become 5, and B on of this will be square outside, so you have the left side pattern. Now you follow this right side formula and break it down into 2 brackets. Know your A, which is 3A in here, put in there. Know your plus sign, follow the formula plus. Know your B is this number, 5B, put in here, close the bracket, you've done the first bracket. Open the second bracket, put your A again, 3A, this time the sign have to be changed to opposite, which is negative, and the B is 5B. Okay, so then you're done. That's how you factor it. If it's more complicated, you have to have 2 layers, and you open the square bracket and simplify, just adding, subtract them, playing around with them. Okay, now this we don't bother to adding, subtract, because remember there are 2 brackets side by side. It means they multiply, right? And that's why each bracket here we call a factor, right? So this is a member of factor. So even though inside they have adding, but the whole 2 bracket here time together, right? They're not adding, subtract, okay? Now inside here, if you see the like term, you can simplify by add and subtract them, but 3A plus 5B is you stuck. You cannot add them inside the bracket. They're not like terms. You cannot add them, right? So remember, even though they have a negative or positive, these 2 brackets is multiplied together, okay? They're not adding, subtract. I'm going to erase now, leave it for you. I'm going to end our lesson today. Good luck with your assignment. I will come up with the assignment to post and follow it. Check the due date. It will be on Saturday, right? The due date usually. And usually you have weekly assignment to back up with what we learn, because if I don't give you assignment, I don't know how to measure your learning. Do you understand or you not understand, right? And so that's the way we measure your learning, and you have the assignment, weekly assignment or quiz. Sometimes you might have 2 of them, like 2 or 3 homework we do in the classroom. But usually in our online now, I reduce it. Each week you only have about 1 assignment or 1 quiz, right? Unless the topic is more and more, I might have 2 of them. Usually it's just 1 or 2, okay? So we're gonna end the lesson now. And our next lesson, still in this unit of factor, which is we call a factor of trinomials, 3 terms, right? So this is 2-term binomials factor or factor of differences square. You will have a last lesson about factor of trinomials. It will be fun. As long as you follow the rules, there's no problem. A lot of you get 100% now in each assignment I put on the online. Many of you, 4 of you, like get 100%. So congratulations for your learning online. And maybe advantage because there's no distraction in our class. I don't have to do a lot of classroom management. Just keep telling you, quiet, disrupt, quiet, so that I can teach. And it getting frustrating, and you hate me for that. Like if I just want you to stop talking, socialize, so you can focus. Now in our learning online, definitely you focus 100% because there are no student talking on the background, and you yourselves not talking with someone else, right? So you see that we only can learn if we focus, okay? We cannot learn if we don't focus, and there's a lot of distraction. And that's why teacher get into trouble with student because try to do classroom management so that all of you can learn. That's just the case, okay? So if you become a teacher in the future, I hope some of you will understand what I'm saying now to you. Okay, so enjoy working. Good luck for your assignment. I hope all of you will earn 100% for this assignment.